Okay, we will be talking about the complex numbers. This is part 1, found in section 6.5 in the textbook. All right, so first of all, let's just talk about real numbers, which is the set of numbers that we work with the majority of the time. There's lots of types. You have whole numbers and integers, rational, irrational. All of these make up real numbers, and any of these could be represented by a point on the real number line. All right, so each one of these does have a location on the real number line. Now, if you switch and talk about complex numbers, the definition for those is that they are of the form z equals a plus bi, where a and b are real numbers. A is the real part of the complex number. B is the imaginary part of the complex number. But the whole number is a plus bi. And then I represents the square root of -1. And we also have this definition that I squared will be -1. So notice this is what we've done before. I is the imaginary unit. We're not talking about vectors. We're not talking about the standard unit vector I. Now, if you want to graphically represent a complex number, then you have to work with the complex plane. Right? Real numbers can be represented on the real number line, but complex numbers will need 2 dimensions, since each one has a real part A and an imaginary part B. So basically, we need 2 axes. We're going to have the horizontal one be what we call the real axis, not the x-axis, but the real axis, and the vertical one will be the imaginary axis. And the way this works is we will take a complex number and represent it using an ordered pair and then graph that point. So for example, the complex number -2 plus 4i, we can represent that as -2, 4. And then if we graph that on our plane, just like normal graphing, you would go 2 to the left and then up 4. So this point represents -2 plus 4i. Then the ordered pair is -2, 4, and is representing the number -2 plus 4i. So we went to -2 on the real axis, since -2 is the real part, and we went to 4 on the imaginary axis, since the imaginary part was 4. All right, here's another one, 3 minus 3i. So the ordered pair would be 3, -3. All right, this one will end up in the 4th quadrant. So the real part is 3 and the imaginary part is -3. So right there, that one point represents the complex number 3 minus 3i. Okay, if you have a number that is purely imaginary, like 5i, that can be thought of as 0 plus 5i. So the real part is 0 when it's purely imaginary, and then the ordered pair will be 0, 5. So when you graph a purely imaginary number, its point is going to be on the imaginary axis itself, right here. So that point will represent 5i. So all the things that are purely imaginary will be on the imaginary axis. And likewise, all the numbers that are real numbers are going to end up on the real axis. So if you're supposed to graph -6, that can be thought of as -6 plus 0i, the imaginary part being 0. The ordered pair will be -6, 0. And like I said, it'll be found on the real axis. So -1, -2, -3, -4, -5, -6. That point right there will represent the real number -6.